Hi, welcome to Pre-Calc, Section 4.7 from the Larson-Hostetler, or 10.6 from the Stitziger book. Inverse trig functions. So we're going to look at what is the inverse trig function and how do we use it? And how do we get only one answer from an inverse trig answer rather than multiple answers? So I got a couple warm-ups here. Why don't you try these first before you go, and then we'll review some of these situations. And I'll come back to you in a minute after you've tried these. So pause and do these. Okay, looking at this first one, I'm given the sine of theta is equal to 3 over 5. Well, the sine is y over r, which is equal to 3 over 5. And so if we set this up, we know that x squared plus y squared is equal to r squared. That's the relationship that from the right triangle part of the unit circle that we can figure out. And it's not a unit circle because I'm calling it 5, but that's okay. X squared plus 9 then is equal to 25 based on this information. So if I solve for x, that's going to be a 4. A lot of you could recognize that because that's just a 3, 4, 5. Pythagorean triple. And so then the cosine of theta is equal to x over r. Well, I give you this information here. Cosine of theta is equal to x over r, so we're equal to negative 4/5 on the cosine. So it looks like I am in the second quadrant over here because the cosine is negative and the sine is positive. Now going over here, I can do the tangent of theta. Tangent is the y over the x, so that's going to be the 3 over the negative 4. So overall, second quadrant, the tangent would be negative for this one. And then the cotangent would also be negative. And then that would be 4 over 3. That's a 3. And then the secant is 1 over the cosine, so it's negative 5 over 4, and the cosecant is 5 over 3. There you go. Those are your 6 trig values, which includes that one. Okay, if I graph the inverse of y equals sine of x, what we do for the inverse, remember, is that we reflect it over y equal to x, because for inverse functions, remember that f of g of x and g of f of x both equal x. So if I do a composition of those, then I get just a flip over this line right here. In other words, we're switching the x's and y's. What I would recommend to you right now is to fold along this line and see if you can replicate this curve over that line, reflect it. Okay, try that and see if you can get that to go. If not, we can do a point by point too. Okay, I hope you tried it. Now, if I look at this, I'm reflected over this line, and so I'm going to come on here, and it's going to be pretty much the same thing. And I'm going to cross just past 3. 1, 2, 3. Why? Well, that would be pi. And I go up to 1 here. So I'm there, and then I get that there. And so this would continue on like this. And this one here would be similar, and it would go like that. Okay? And now this one's a little bit trickier. I like to just take a point 0, 1 and change it over to 1, 0. So that's what I'm going to get there. If I take some other points, and so if I take this is pi over 2, 0. So I'm going to plot 0 pi over 2. And then this one is pi, right? Pi, and then that would be at negative 1. So just above 3, I'm going to be at negative 1. So I'm going to get something that looks like this. And then if I go down here, I'm going to have the symmetry there a little bit, 1.57. And then at 1, 2, 3 down here, I would be at negative 1. Okay? Not great looking, but there we go. What you can do then is you can reflect this over the y-axis just to make sure that this looks appropriately. I'm sorry, over y equal to x. So these are inverse functions. Oh, wait a second. Function. What's a function? Oh, for every x, there's one y. Well, if you look at this, for any x, here I have 2 y's. In fact, I have an infinite number of y's if I continued this out. So what happens is that if I just take the inverse of the sine curve as I see it, I will not get a function. So that is some of the considerations that we have to make sure about to see if this is a function. So we have to make sure the sine or cosine pass a horizontal line test so the inverse satisfies that vertical line test. Well, what they did then is they said, okay, where can I take a strictly increasing or a strictly decreasing part of the curve to make it an inverse that we can deal with that would be a function? Well, what happens here is that we did this. For the sine graph, we limit it from negative pi over 2 to pi over 2. And so when I take the inverse of that piece, what happens is that I have my function because I just have this piece right here. That would be strictly increasing. Similarly, for this cosine one, well, it's going to be a different interval though. They took 0 to pi, and they said, okay, this is strictly decreasing, so I'm going to use that interval. So on the inverse, the range would be from 0 to pi. And that piece would give us an inverse function. So when I'm talking about an inverse cosine, I just want to look for one answer, not infinitely many. And so that's what we did here. Now going down here, let's explain some of these things. First of all, the inverse sine. Inverse sine can be written like this, or it could be written as the arcsine. This was quite popular a long time ago. I think it's because of textbooks and they didn't have to offset this -1. That'd be my guess, but maybe there's another reason. And this is both of these are exactly the same thing. So you'll see the inverse sine written like this, and you'll see it written as arcsine. Inverse sine is not 1 over the sine. This is convenience notation, which means that it is an inverse. So we say the inverse sine of x. 1 over sine, remember, is the cosecant. So those are two totally different things. Inverse sine, 1 over the sine are not the same thing. Okay? So here they set up your domain. And this is what we just talked about up above with the graphs, is that if x is between -1 and 1, and this is what we're looking at here on this blue patch here, my x's go from -1 to 1. So for that, I get out one y value in all these different pieces here, and that goes from -pi over 2 to pi over 2. Inverse cosine, the domain is -1 to 1 because we're switching x and y's. And so I'm going to go from -1 here over to +1 on the x's. And then on the y's, we're going to go from 0 to pi. So that's where that comes from. The inverse tangent, we'll just have one of those pieces that are flipped over, and I'll show that in a second. And then the inverse cotangent, inverse secant, inverse cosecant, we don't deal with too much. So this would be the graph of just the arcsine. This would be the graph of the arccosine. Arctangent only takes one of those pieces and reflects that over y equal to x. Just one piece. If it had all the other pieces going up, then it would not be a function. And then you can look at these other ones for your information. Okay, then we're going to get to some examples here. When we see y equals sine of x, and I want to know when the sine of x is equal to -square root of 3 over 2. How many solutions do we get for that? Well, this is an infinite amount of solutions. Now, since we use this notation right here, this is asking only for one answer because it is a function. Arcsine is a function. So when I see this, I want to know what the arcsine is for this. Now, since we put out answers from only, now I'm on the unit circle, quadrant 1 and quadrant 4 for the arcsine. Well, why is that? Well, I said that the arcsine goes from -pi over 2 to pi over 2. So I can include all the answers for that. So what this means then is what angle measurement gives me a sine value of -square root of 3 over 2. Well, so when is that true? Well, we might say that it's true at 5 pi over 3. Well, that is not in our range that we want. And so instead of using 5 pi over 3, I'm going to use -pi over 3. So this would be the one answer that we get out of this situation. Okay, so you got to look at the domain for the sine. So inverse sine of 0.5, I got to be in either the first quadrant or the second quadrant of the unit circle. And once again, well, this one's positive. So what that would be then is just pi over 6. What angle measurement gives me a sine value of 0.5? Okay, look at this one. What sine value gives me, or what angle measurement gives me a sine value of 3? Well, I hope you realize that this is undefined. There is no solution for this one, because sine does not go above 1, and so my domain, this does not satisfy my domain. Then this one's arc cosine of 0. Arc cosine of 0. Now, what happens with the cosine is that the domain's a little bit different. I'm sorry, the range is a little bit different. For the cosine, we're going to go from 0 to pi. So on the unit circle, I only could find answers in these two quadrants. Well, when is the cosine 0? It would be at pi over 2. Is our answer in this interval? Yes. Okay. And then how about some more here? Arc cosine of negative square root of 2 over 2. Cosine is going to be in the first or second quadrant. I'm going to be over here, so my answer would be 3 pi over 4. And we look here, does that satisfy this range? Yes, it does. Okay, now inverse tangent of square root of 3 over 3. The inverse tangent uses the same quadrants as the inverse sine. Goes from negative pi over 2 to pi over 2. So when I look at this, I remember that this is the same thing as 1 over square root of 3, which is 1/2 over square root of 3 over 2. And so what I'm looking for is a positive value, which would be the first quadrant, and my y value is 1/2, and so it would be this triangle here. So I'm back at pi over 6, first quadrant. Inverse tangent of negative 1. So once again, I'm going to be in this quadrant. Tangent is negative in the fourth quadrant, so it covers all the positives here, all the negatives here. And negative 1 would be at this value right here, which would be negative pi over 4. We do not say, once again, we do not say 5 pi over 4. We say negative pi over 4. Okay? Did I say 5 pi over 3 here? Yeah, I think so. Okay. Yeah, I knew I said something wrong there. That's 7 pi over 4. Thanks. Okay, and then you'll see one of these every once in a while. Inverse secant of this right here. Well, this is the same thing as the inverse cosine of the reciprocal of this. I don't know if you can tell this or not, but this is the reciprocal of... This is saying the same thing as the inverse cosine of square root of 3 over 2. If you take the reciprocal of this, this is 3 over 2 square root of 3. Rationalize, then the 3's would cancel, so I get this. So what we're doing is we're taking the reciprocal of the trig value. Yes? And so I can now read the inverse cosine. Inverse cosine would be in these two quadrants. This is positive first quadrant, and then that would be pi over 6. Okay? So just remember to make sure that you are in the correct quadrant when you're doing these things. That's the biggest thing. And with the inverse sine and inverse tangent, you're going to be using the first or fourth quadrant because that corresponds with this. And for the inverse cosine, you're going to be using the first and second quadrant, which corresponds with that. And that's where your answers are going to come from, all because we want one answer because it is a function. Okay, on these next ones, then I want you to use your calculator. And so we'll show you how to do that on the Inspire. Arctan of negative 2.83. So what we do is we just go to our calculator, and we can find this trig function right here, and here's the inverse tangent. And then we can type in the value that we have there, and I can enter this, and then that is my angle measurement. I am in radian mode, and so this would be radians, and that's what you're going to come up with. Notice if we have a negative value, I'm going to get a negative angle measurement, which puts us in the fourth quadrant. That should be right. Go try, and then I'll show you how to do this graphically. And this is what I get. Okay, so I made a mistake on this first one, but inverse sine, negative 0.047, I get that. And inverse cosine of 3, we already talked about that, and that's what happens on the calculator. Look at what it happens with this. I did the inverse cosecant. If you have an 84, it doesn't do this. So you would have to do this on the 84, TI-84. And so what you do is you take the reciprocal of the inside value to find the inverse value for the cosecant, and it would be inverse sine of that. And then if I enter this to get the decimal representation, I get this here. All right. Graphically, if I go back to number 9 to do this one graphically, I'm going to graph the tangent and then this value. And so this tells me when the tangent is equal to this, and that will give me my angle measurement. I didn't graph the inverse tangent because you're just plugging in that value, but I graphed the tangent is equal to this right here. And so if I find the point of intersection, I can do that here. And this is, if I look at it here, I want this point right there. Okay, I want that point because I need to be from negative pi over 2 to pi over 2. I can't take any of these other values unless if I'm looking for something different. But since it's just inverse tangent, I want one value, and there it is. Okay, let's finish up this last part. Properties of inverse functions. These are inverse functions, so remember that f of g of x is equal to x and g of f of x is equal to x if we have inverse functions. So if I have the sine of the arcsine, that's going to be equal to x, and arcsine of the sine of y is equal to y. The only problem is domain issues, because the arcsine will only give us one value, and that value is between negative pi over 2 and pi over 2. However, we might get well, in this case, we might get a sine of a value that's not between that interval. So we just have to make sure that we end up there. So for example, this one, arcsine of sine of 3 pi over 2. You might say that we get 3 pi over 2. But the problem comes in is that if I look at this value right here, sine of 3 pi over 2 is going to be negative 1. And if I take the arcsine of that, I need to be in one of these two quadrants. Oh, endpoints there too. But I need to take care of this value, which would not be 3 pi over 2 because I'm only looking at from negative pi over 2 to pi over 2. So this answer is actually negative pi over 2. So it's not a straight cancel. So you got to think about that a little bit. Take the sine value, get it, and then figure out where you are in these two quadrants. Now this one is a little bit better because arctan of negative 5, and then the tangent of that would just be negative 5. I don't have those same considerations because I'm taking the tangent of that value, boom, I'll be okay. So those two do cross off when you do the tangent on the outside, arctan inside. If the arc functions outside, though, you might have to pay attention to the domain issues. Now, if I evaluate these, what we want to do is, and you're going to have to use your triangles, right triangles, to figure these things out. So the steps for this: build a right triangle with the inside information and read off that triangle with the outside information. And with all this, you need to know your SOHCAHTOA. So hopefully you know that. Okay, so what happens here? For example, we're going to take a right triangle, and I would write the right triangle like this every single time. If I build with this information, arcsine of 3 over 5, this means my y coordinate is going to be 3, and my hypotenuse is going to be 5. And if I look at that and I call this theta, this would be my 3, and this would be my 5. So with respect to this angle, this is opposite, this is hypotenuse. That's what the sine is telling me. So the inside information tells me to build the triangle. Now I need to find this missing piece. That's Pythagorean triple, so I'm okay. So now with this piece, I need to read off what's left. So I know that the tangent is opposite over adjacent. So from this angle, I need to read off 3 over 4, which is my opposite over adjacent. And so my answer is 3 over 4. Inside information, build the triangle. Outside, read it off. Okay, so if we do this one, build a right triangle, call this theta. And if I build this, this is arcsine again, so this would be square root of 2, and then this would be a 6. We'll have to figure out the negatives, and we'll probably ignore the negatives in some respects, but we'll have to talk about it. Okay, so if I find this missing piece, if I take 36 minus 4. Remember, if you know the hypotenuse, you subtract. So 36, oh, that would be minus 2. Sorry, square root of 2 is squared. So this would be 34. So this would be the square root of 34, this missing piece. And if I read off the cosine now, that would be square root of 34 over 6. Now, should I put a positive or negative on this? Well, the arcsine value is going to be in this quadrant right here because it's negative. And so if I'm in the fourth quadrant, what's the value of the cosine in that quadrant? Well, it's got to be positive then. Okay? Now, if I look at these get a little bit trickier, but it's just with variables. So I'm going to build my right triangle, put theta here, and arctan of 1 over x. So that means my opposite over adjacent is going to be 1 over x like that. What's my hypotenuse then? Well, a squared plus b squared square root would give me that hypotenuse. So now I'm going to read off the sine. If I read off the sine, that's going to be the opposite, which is the 1, over the hypotenuse. And I don't expect you to rationalize that denominator. That's it. Okay, so then you're okay. Then arcsine, how about this one? If I build this triangle, maybe pause and try this. Arcsine is equal to 3x. If I don't have a denominator, what am I going to write? Well, that's a 1. So it's 3x over 1. Unfortunately, I did a lot of arcsines here. And then this piece right here would be, remember you subtract if you know the hypotenuse, so it's 1 minus 9x squared. So if I read off the secant, cho, sha, ko, that's the reciprocal of that. If I take the secant, that's going to be the hypotenuse divided by the adjacent, since it's the reciprocal of the cosine function. So this is going to be equal to 1 over the square root of 1 minus 9x squared. Voila. Build these right triangles. This will help you out quite a bit. All right, that's all I got. Lots of stuff there. The last part is a little tricky, but I think you can get that, and I hope this helps. Have a great day.